Space is mostly empty, mostly dark, and almost entirely silent. That is not a poetic way of putting it. It is a description. Tonight we are going to walk outward. We will start with the ground under you, which is turning more slowly than it used to, and finish about 5,000 light years away at the coldest place anybody has ever measured. 14 things, all of them measured rather than guessed. Where the measurements disagree, I will say so. There is no rush in any of this. You do not have to follow every number. If you are here to fall asleep, that is a perfectly good way to listen. The day is getting longer. The day is not exactly 24 hours, and it is not a fixed length. The moon pulls on the oceans. The water bulges slightly towards it, and because the earth is turning underneath that bulge, the water drags against the seafloor and the coastlines. That drag is small, and it is constant, and it acts like a brake. The earth is slowing down. A day gets longer by roughly 2 milliseconds per century. That sounds like nothing, and over a human life it is nothing. Over hundreds of millions of years it is not. Some fossil corals lay down a fine band each day and a thicker band each year, so you can count the days in an ancient year. Corals from around 400 million years ago suggest a year of about 400 days. The days were shorter, roughly 22 hours. We also measure it directly now. Atomic clocks keep a perfectly even second, while the turning Earth does not, and the two drift apart. When the gap gets close to a second, a leap second is added to bring them back together. 27 have been added since 1972. The rate is not perfectly steady, either. Earthquakes, the movement of the core, and melting ice all nudge it slightly. In recent years, the planet has even sped up a little. The moon is leaving. The same tide that slows the Earth does something to the moon. The ocean bulge is not exactly under the moon. The Earth turns faster than the moon orbits, so the bulge is dragged slightly ahead of it. That mass, sitting slightly forward, pulls the moon along its orbit. Energy is passed from the spinning Earth to the orbiting moon. An object given energy in orbit moves outward, so the moon is receding. We know the number very precisely, and the way we know it is unusual. Apollo 11, 14, and 15 left panels of corner reflectors on the surface, and 2 Soviet rovers carried more. A corner reflector sends light straight back the way it came, whatever angle it arrives at, so an observatory can fire a laser at the moon and catch a few of the returning photons. From the travel time you get the distance to within a few centimeters, the moon is moving away at about 3.8 centimeters a year, about the rate your fingernails grow. Run that backwards, and the moon was closer, and the tides were far larger. Run it forwards, and eventually the moon will be too far away to fully cover the sun, and total solar eclipses will end. That is several hundred million years off. The silence. Sound is not a thing that travels on its own. It is a pattern of pressure moving through something. Air, water, steel, rock. Take away the something, and there is no pattern to carry. Space has almost nothing to carry it. Interstellar space holds roughly 1 atom in every cubic centimeter. A cubic centimeter of the air around you holds about 10 to the 19th. That is a 1 followed by 19 zeros. So an explosion out there makes no sound. Not a quiet sound. No sound. There is a careful exception, and it is worth stating properly. In places where gas is denser and hotter, pressure waves do travel. Astronomers have traced ripples through the gas filling the Perseus galaxy cluster, spreading out from the center. If you work out the pitch, it is far below anything a human ear could hear. by a very large margin. So the honest version is not that space cannot carry sound. It is that almost everywhere there is not enough of anything for sound to move through, and where there is, the notes are impossibly deep and impossibly slow. The day longer than the year. Venus turns very slowly, and it turns the wrong way. One full rotation against the stars takes about 243 Earth days. One full orbit around the Sun takes about 225. So on Venus, a rotation takes longer than a year. The rotation is also backwards. Almost everything in the solar system spins in the same direction, the direction it orbits. Venus does not. Seen from above the solar system, it turns the other way, which means that on Venus, if you could see anything through the cloud, the sun would rise in the west. There is one more twist. Because the rotation is slow and backwards and the orbit is quick, the time from one sunrise to the next is not 243 days. The two motions partly cancel. A single day to night to day cycle on Venus takes about 117 Earth days. Why it ended up this way is not settled. The leading explanations involve the thick atmosphere and tides from the sun acting over a very long time, and possibly a large impact early on. This is one of the places where the honest answer is that we do not know yet. 3 turns 2 years. Mercury is locked to the sun, but not in the way the moon is locked to us. The moon turns exactly once per orbit, which is why we see one face. Mercury turns exactly 3 times for every 2 orbits. It is a different lock, and it is stable for the same reason. The planet is not a perfect sphere, and the sun's pull settles it into a whole number rhythm. The consequence is strange. A rotation against the stars takes about 59 Earth days. A year takes 88. But sunrise to sunrise takes 176 Earth days. Exactly 2 Mercury years. So a day on Mercury lasts 2 of its years. There is a further oddity. Mercury's orbit is stretched, so its speed around the sun changes a lot. Near its closest approach, the orbital motion briefly outruns the rotation. From certain places on the surface, the sun would rise, stop, move backwards for a few days, stop again, and then continue. We did not work this out from the ground alone. Radar measurements in the 1960s overturned the earlier assumption that Mercury kept one face to the sun, and the spacecraft that followed confirmed it. Old light. Sunlight takes about 8 minutes and 20 seconds to reach us. That part is easy, and it is exact, the distance divided by the speed of light. The interesting number is what happened before that. Energy is released in the core of the sun, where hydrogen fuses into helium. To get out, that energy has to cross the body of the sun, and the interior is not transparent. A packet of energy is absorbed and re-emitted constantly, in a random direction each time. It does not travel outward. It staggers. A random walk covers ground very slowly. The result is that energy released in the core takes an extraordinarily long time to reach the surface. Here I have to be careful, because this is a number you will see stated confidently and differently in different places. Estimates range from about 10,000 years to a few 100,000, depending on the assumptions used about density and opacity. The often quoted 100,000 is in that range, but it is not a measured value. What is not in doubt is the shape of it. The light falling on your hands outside took 8 minutes to cross the gap, and something like the age of human civilization to get out of the sun. the mountain you could not see. Olympus Mons on Mars is the largest volcano in the solar system. It is about 22 kilometers high, roughly 2.5 times the height of Everest above sea level. But the height is not the interesting part. The width is. It is about 600 kilometers across. That is wide enough to cover a large country. And because it is that wide and only that tall, the slope is very gentle, around 5 degrees in most places. Walking up it, the ground would feel almost flat, which produces a strange result. If you stood on the flank of Olympus Mons, you would not be able to see that you were on a mountain. The summit would be far over the horizon. Mars is smaller than Earth, so its horizon is closer, and the whole structure is far too large to take in from the surface. The edge is different. The volcano does not taper away gradually at its boundary. It ends in a cliff, in places several kilometers high, running around much of the base. It grew so large partly because Mars has no moving plates. On Earth, a plate slides over a hot spot, and you get a chain of islands, each one built and then carried away. On Mars, the ground stayed put, and everything piled up in one place for a very long time. The storm is shrinking. The Great Red Spot is a storm in Jupiter's atmosphere, and it has been watched for a very long time. There are drawings of a spot in that band going back to the 1600s, although whether that is the same storm is genuinely uncertain. Continuous records begin in the 1800s. Those records show something clear. It is getting smaller. In the late 1800s, it was measured at around 40,000 kilometers across. It is now roughly 16,000. Wide enough to swallow the Earth, but no longer wide enough to swallow 3. As it narrows, it has also grown taller and rounder. It was a long oval. It is becoming closer to a circle. Nobody can tell you confidently what it will do next. It may keep shrinking until it breaks up. It may stabilize. Storms on Jupiter have merged, split and faded before, and the record is too short to know what is normal. It is a good reminder about the outer planets. We have had close-up data for about 50 years. That is a very short window to observe something that may run on cycles of centuries. The first measurement of light. For most of history, light was assumed to arrive instantly. Ole Romer was working at the Paris Observatory, timing the eclipses of Io, the innermost large moon of Jupiter. Io passes into Jupiter's shadow on a very regular schedule, a little under every 2 days, and it was being used as a clock. The clock did not keep time. When Earth was moving away from Jupiter, the eclipses ran late. When Earth was moving towards it, they ran early. Over the course of a year, the timings drifted by around 22 minutes and then came back. Romer's explanation was that nothing was wrong with Io. The light simply had further to travel when the planets were further apart, and it took time to cross the extra distance. That is the first real evidence that light has a finite speed. He did not publish a value in modern units. Christian Huygens took the timing and the best available estimate of the size of Earth's orbit and worked out a figure. It came out low, mostly because the size of the orbit was not yet well known, but it was the right order of magnitude. The method was sound. The measuring stick was not yet accurate. That is a very common shape in the history of measurement. 10 meters of ice. Saturn's rings are about 280,000 kilometers across. They are, in places, around 10 meters thick. Take those two numbers together, and you have an object with proportions unlike anything in ordinary experience. If you shrank the rings to the width of a football pitch, they would be very much thinner than the paint marking the lines. They are not solid. They are countless separate pieces, mostly water ice, ranging from grains of dust to boulders, each on its own orbit. Two further things are worth saying, and both come from the Cassini spacecraft, which spent 13 years there and finished by flying through the gap between the rings and the planet. The first is that the rings appear to be young. The measured mass and the rate at which they are being darkened by dust falling in from outside both point to an age of perhaps 100 million years or so. That would make them far younger than Saturn. This is debated, and not everyone agrees on the reasoning. The second is that they are draining. Ring material is falling into Saturn's atmosphere. On the current estimates, the rings are a temporary feature, and we happen to be here while they exist. Rain that is not water. Titan is Saturn's largest moon, and it is the only place besides Earth where we have found standing liquid on the surface. The liquid is not water. It is methane and ethane, the same substances that are gases here, held liquid by the cold. Titan's surface is around minus 180 degrees. It has a full weather system. Methane evaporates, rises, forms cloud, and falls as rain. The rain runs into channels, and the channels run into lakes and seas, mostly near the North Pole. The largest, Kraken Mare, is bigger than the Caspian Sea. The rain falls slowly. Gravity is weak, and the air is thick, so the drops are large and drift down at a walking pace. We know this in unusual detail because a probe landed there. The Huygens lander was carried by Cassini and released, and in 2005 it descended through the haze and touched down on a plain of rounded pebbles. Rounded, which means something moved them and wore them smooth. It kept transmitting for about 90 minutes after landing. It is the most distant landing anybody has made. How far the signal has to go. Voyager 1 launched in 1977, and it is still transmitting. It is now more than 24 billion kilometers away, and the distance grows by about 1.5 million kilometers a day. It crossed out of the Sun's bubble of particles in 2012 into interstellar space. Radio travels at the speed of light, which makes the distance easy to feel. A command sent from Earth takes a little over 22.5 hours to arrive. The reply takes the same again. A single question and answer takes nearly 2 days, and that figure gets longer every day. The transmitter runs on about 22 watts, less than a dim household bulb. By the time it reaches Earth, the signal is fainter than almost anything else we listen for, and it is picked up by dish antennas tens of meters across. The power source is a slow one. Heat from decaying plutonium turned into electricity. It fades a little each year, and instruments have been switched off one by one to stretch what is left. The last of them will go quiet sometime in the 2030s. It also carries a gold-plated record with sounds and images from Earth. That part is often described as a message. It is more honest to call it a gesture. Nobody expects it to be found. Planets with no sun. Not every planet has a star. Some were thrown out of the system they formed in by a close pass with a larger planet. Others may have formed alone, out of a collapsing cloud too small to ignite into a star. Either way, they drift between the stars in permanent darkness. Finding something that emits almost no light against a black background is difficult. The main method is elegant. When a massive object passes almost exactly in front of a distant star, its gravity bends the starlight and briefly brightens it. The shape and length of that brightening tells you the mass of the thing that passed. That is how the first free-floating planetary mass objects were identified. The events are brief, they never repeat, and they require watching millions of stars to catch a few. Estimates of how many there are vary a great deal, and some of them are very large. I will not give you a confident number because the field has not settled on one. More recently, the James Webb Telescope found pairs of planetary mass objects drifting together in the Orion Nebula with no star between them. How pairs like that form is, at the moment, unexplained. Colder than empty space. The universe has a background temperature. It is the leftover heat of the early universe, spread evenly in every direction, and it sits at about 2.7 degrees above absolute zero. You would expect that to be the floor. Nothing sitting in space should be able to get colder than the space around it. One place is colder. The Boomerang Nebula is a dying star about 5,000 light-years away in the process of shedding its outer layers. That gas is not drifting off gently. It is being expelled very fast, and expanding gas cools as it expands. The same effect as a can of compressed air going cold in your hand, on an enormous scale and running continuously for over 1,000 years. Measurements put it at about 1 degree above absolute zero, colder than the background radiation that fills the rest of the universe. It is the coldest naturally occurring place anybody has measured. Colder places exist, but they are all in laboratories on Earth, made deliberately, and they last for fractions of a second. That is where we will stop, about 5,000 light-years out, at a cloud of gas that is quietly colder than the sky behind it. 14 things, and something they have in common. Almost none of them were found by going and looking directly. The moon's retreat was measured by bouncing light off a mirror the size of a briefcase. The speed of light came out of a moon that kept running late. The slowing of the Earth was read out of fossil coral, one band at a time. Most of what we know about space was worked out by noticing that a number was slightly wrong and taking that seriously. Thank you for listening. Sleep well.